Hello everyone. I have a question for you. Which of the common used objects has the highest hardness? If you thought about diamond, yes, that's correct, it's the hardest material. However, it's not used by everyone daily. Other pick may be sandpaper, and namely the silicon carbide that is used to for the grains. Here I have a particle of silicon carbide, and it's pretty hard at 2500 Vickers, whereas a diamond on the diamond file has around 10,000 Vickers. Other picks could be ordinary glass bottle. Those are usually made from a soda lime glass, and the hardness of that is around 530 in Vickers. Other type of glass that is used on electronics like smartphones is called Gorilla Glass, and it is an ion exchange strengthened glass and has higher hardness of around 630. The most obvious picks would be steel, and specifically hardened steel. We can make from hardened steel a knife. That would be a martensitic stainless steel, a tool steel for a wrench, or a high carbon steel for a steel file, or stainless martensitic steel for tools of a multi-tool like a knife. And it had stainless steel after hardening can have various amount of hardness, and I measured for those items that the range is around 500. This translates to around 50 HRC. The knife is around 600, which is around 55 HRC, and the steel file 850, which is around 64 HRC. Other common used metals include aluminum, namely aluminum alloys used for bottles or deodorant cans. That's the most common alloy of it, and it's pretty soft at 90 Vickers. The coins are made of specific alloys. Not all of them, because the cents are just ordinary steel that is copper plated. Mild steel has a hardness of around 130 HV. Not very hard. The euro cent is the alloy named Nordic Gold, with mainly copper and additions of aluminum, zinc and tin, for overall hardness of around 90 HV. And on the euros, the silvery part is made out of nickel brass, so a nickel-based alloy. Also from steel are made locks, padlocks. That is usually that's a carburized steel and hardened, so only the surface is hard, and it would be also around 600 HV. And out of all of items here, there is one imposter. A pen? Why would a pen be here? Well, the outer shell, it's made from a polymer, a thermoplastic. That's pretty soft, that's very soft. However, there is a big surprise waiting for you inside. The spring, that's spring steel, around 400-500 HV. Not super hard, but look at this dude. What's that? TC ball. TC stands here for tungsten carbide. Oh yeah. That's the good stuff. This is, in my opinion, the hardest material of an item that everyone uses daily. Everyone uses a pen. Children and workers in almost every job use a pen. But I will use a pen in a different way. This ball, at the end, only this part is made out of sintered tungsten carbide and has the hardness of around 1800 HV. And I will use that for my own hardness tester. I will replicate the Brinell method, where an object that needs to be tested is laid flat, and then the ball with a known diameter, here it's 1 millimeter, is pressed into this object with a known force, and after that the indentation in the shape of a circle is measured, the diameter is measured, and in such a way we can calculate the hardness of the base material. And I will try to make such a tester with common tools, so that everyone that is interested could replicate my study and make themselves our own hardness tester that will be more accurate than the common method of using just a steel file to test the hardness of material. Yeah, here you can see that the wrench is softer than the file. The glass that I said it's 530. You may not believe that a steel file is harder than a glass, but it scratched the surface pretty good. The silicon carbide, it won't have any problems making a mark. However, I need to find a sharp edge of this carbide. Yeah. And diamond, no question. So let's go to my lab. One more thing. I could add to you that the hardness of Gorilla Glass is, as you may know from a famous YouTuber, is around 6 in the Mohs scale, the scale used for testing the hardness of minerals by scratching one of them with another. And that is pretty good representation of around 600 HV. You could tell that 6 in Mohs scale is around 600 HV. Hardness of diamond, also 10 in Mohs scale, is 10,000 HV. The scale of Mohs is non-linear, that's why it's hard to use it for scientific purposes. I'm removing just the ball with the help of pliers. Our original indenter is almost $200 and a ballpoint pen is almost free. Now I take 2 pieces of hardened steel and I will pinch the ball between them and put my weight on them. It was difficult to balance my weight on this very small ball. That's why I assume the real weight applied was less than my own weight, because the steel plate had a contact with the lower plate. The force wasn't transmitted only through the ball. That's why the hardness measurement result will be skewed. I will now use the microscope from the Vickers hardness testing machine to measure the diameter of the indentation. The result of 1070 is way off. It should be around 600. That means that the application of weight has a very large error. That's why I will now remove the whole assembly of ball with a holder from the ballpoint pen mounted in a vise and then use the Vickers hardness testing machine to apply the load. I've placed the ball now exactly under the Vickers indenter, and I will put a piece of hardened steel between those two indenters, and now the weight is applied. From the top, the Vickers pyramid is being pushed into the steel, and from the low end, the Brinell ball is being pushed into the steel. Vickers hardness on top is 611 Vickers. The Brinell hardness on the bottom is 564 Brinell, which translates to 615 Vickers. So 615 versus 611, very close. I will now stand on the vise and press the ball into the steel with the force of my weight. The measured diameter is around 400 micrometers, and the hardness in Brinell is around 540 Brinell, which translates to 590 in Vickers. The value, it's pretty close to the 611 measured with the laboratory equipment before. You need to remember that the steel is not uniform, the hardness value varies. Now the sintered carbide ball will be tested for hardness. The hardness is 1800 in Vickers, it's very hard. Brinell test, unlike Vickers, is dependent on indentation force used. The optimal indentation diameter is around 3/8 of the indenter diameter. In this case, it should be 375 micrometers. That was more or less achieved with 75 kilograms of indentation force. When much lower force of 10 kilograms is used, the indentation is significantly smaller, as 155 micrometers, and the error is bigger. Diamond pyramid of Vickers was pressed into the carbide ball and left a mark there. Now, when the carbide ball was pressed into the steel, the mark left by the pyramid is still visible.